In my previous video, we introduced sigma notation and talked about the basics of it. Now let's actually use sigma notation. And so I'm going to do two examples, and then I'll give you a chance to kind of practice with two examples. And it should be a pretty short video. So I'm going to assume you've watched my previous video. And so what we're going to do here is I'm first going to expand this out using what we know about sigma notation, and then I'll add the values together. So it looks like I'm starting with an index of 1. So we're going to do 1, and then we're going to stop at 3. So I have 1 squared plus 2 squared plus 3 squared. I just took each I value, substituted into my expression. I'm increasing by 1 every time. 1, 2, 3, and then I'm stopping at 3. Each of these values we're going to add. So this would be 1 plus 4 plus 9, and it looks like that's going to be 14. So this expression is equal to 14. Let's do another one. So in this example, we're starting with an index of 1 and we're stopping at 5. So I'm going to do 2 times 1 plus 1, and then I'm going to add 2 times 2 plus 1, and then I'm just going to expand it out. So I expanded it out, and now I'm going to just basically do the math on this. I'm going to evaluate these little expressions, and I'm going to add them up. And so once I actually evaluate each of those for each index, I end up getting a sum of 37 for that one. Now, we're moving on to the next slide. I've got 2 more examples, and I want you to, actually I got one little typo right here. It looks like on my first problem I have an N, and since we have an I in our formula, I'm going to change that to an I. Okay. But other than that, everything should be straightforward. I want you to try this, pause it, try this one on your own, and then hit play whenever you're ready for me to talk about it. So I'm going to get started on this first one. So I'm going to start with substituting in a 1 for I. So it looks like we have 1 times 1 plus 1. And then I'm going to add that to 2 times 2 plus 1. Don't make the mistake of accidentally substituting a 2 in there. That's no good. And then my third one is going to be we're substituting a 3 now. 3 times 3 plus 1. So if I add those up, let's simplify each of these. 1 times 2 is 2. 2 times 3 is 6. 3 times 4 is 12. And those are the numbers we're adding up. That looks like that's going to be 20. So for this first one, you should have gotten a 20. And now let's look at the last one. I gotta be careful because this time we're actually starting at 2. Don't let that trip you up. So I'm going to substitute in 2 over 2 plus 1. Okay, because I started with 2. And then I'm going to substitute in 3 over 3 plus 1. And then lastly, I'm going to substitute in 4 over 4 plus 1. Okay, I'm just substituting each of these values in for n and making sure that I stop there. Now lastly, let's do our evaluation and get our sum. We have 2/3 plus 3/4. Oops, gotta be color coded. Stick with the red. 3/4 plus 4/5. And oh man, I gotta get a common denominator to add these up. I'll pause the video and work this out so you don't have to hear me bumbling through it. Okay, made a mistake here because I'm doing this a little fast, but I found that the common denominator would be 60. So I rewrote all these with a denominator of 60. I wrote this one by multiplying by 20 over 20. This one by multiplying by 15 over 15, and this one by multiplying by 12 over 12, and I get this. So I just need to add those numerators up and simplify. And I end up getting 133 over 60. That might simplify, I don't know, but I think I'm done. So let's just stop there and call it a day and say that this sum is 133 over 60.